Okay, today is lesson 6, exponent laws part 2. And before we start, we're going to do a quick review of our laws that we've learned so far. The first law is what we call the power law. It states that if the bases are the same, like they are in this first example, they're both x's, then we can add the exponents. The base stays the same and we add 7 plus 4. So we can simplify this to x to the power of 11. So remember, the base has to be the same, and then we can add the exponents. Next one we learned about was quotient law. So first, if the bases are the same, then we can subtract the exponents. And we also learned that everything has an invisible power of 1 on it if it's not written. So the first one here, we have to use product law on the top to simplify first. Then we use our exponent laws, our quotient law to subtract. So 11 minus 8 is 3. So my answer is y to the power of 3. Now, next one we have to throw in a little bit trickier. We have a few different elements. We have coefficients, which are the numbers in front of the variables. Then we have a's, and then we have b's. So first off, I'm going to deal with my coefficients. The coefficients you multiply regularly. So I multiplied 2 times 4 to get 8. For my a's, I'm going to add the exponents. Remember the invisible 1, so it becomes 8 to the power of 3. And same thing for the b's, b to the power of 5. And this is my simplified answer. Same thing works for division. I have coefficients, I have p's, and then I have q's. So I notice that on the bottom, both of mine, I need to add in invisible ones. So I have 15 divided by 5, which is 3, p to the power of 4 minus 1, which is 3, and q to the power of 3 minus 1, which is 2. So to summarize, if you have the bases the same and you're multiplying, you can add the exponents. If you have the bases the same and you're dividing, you can subtract the exponents. And then just a reminder from lesson 3, everything to the power of 0 equals 1. So we can use the above exponent laws as shortcuts to simplify patterns in other forms. So let's complete the table below. Okay, 2 to the power of 2, all to the power of 3. So what that means is I'm taking my base, which in this case is 2 to the power of 2, and I'm multiplying it by itself 3 times. Okay, so that means it's 2 to the power of 2 times 2 to the power of 2 times 2 to the power of 2. Now I'm going to take the time and write it out individually. 2 to the power of 2 means 2 times 2. 2 to the power of 2 again. And 2 to the power of 2. So when I write it as a single power, it becomes 2 to the power of 6. There's 6. Now go back to your original here. What do you notice about the power of 6? How could we have possibly got that from our original? Okay, try the next couple, see how it goes. So that brings us to our next exponent law. It says that if we have, this one's called power of a power, which means I have two powers right next to each other as right here. If I have that, then I can multiply them. Oh, I shouldn't use my time symbol because it looks like an X. Okay, m times n. So to raise a power to a power, we multiply the exponents. Okay, so any type of exponent law that has a variables inside, we can use this to apply it to. So this one, a times b to the power of m becomes a to the m times b to the m. A to the m times b to the m. So the bracket has expanded to include more parts, but the rules are the same. So everything inside the brackets needs to be raised to the power of m. And then just to complicate things a tiny bit more here, if we have a to the power of m times b to the power of m all to the power of m, we have to take the n in for each exponent and multiply it because it's power of a power. So it becomes a to the power of m times n times b to the power of m times n. So these ones can get a little complicated, but the more examples you see, the better you'll get at it. So let's try some examples. All right, example 1. Write as a single power. So I have -5 to the power of 3 all to the power of 2. So I see that there is a product, or sorry, power of a power here, which means I leave the base the same and I multiply the exponents to become 6. That is my single power. Okay, next one, that negative sign is just hanging out front. I'm going to leave it there. And then I'm going to use exponent laws. 3 to the power of 4 times 3, which is 12. All right, try the next two on your own. The placement of your brackets is really important for D. You need to leave your base of -2 in brackets in order for the answer to be correct. Now let's try with variables. Multiply the exponents and multiply the exponents. Y to the power of 15. Seems easy enough. So let's step it up a notch. Example 2. Whoa, things just seem to have got way more complicated. So now I have a whole bunch of things multiplied together inside the brackets with a power outside. So we call this a product of a power. The 3 on the outside here needs to be multiplied by every exponent on the inside. So it becomes 3 to the power of 2 times 3, which is 6. A to the power of 2 times 3, which is also 6. And b to the power of 4 times 3, which is 12. So this here is my answer. Right, try that on the next couple, and remember that if there's nothing written there as an exponent, for example, C, 5, you have to put an invisible 1 in for the 5. Same as the D here. D to the power 1 becomes D to the power of 2 in my answer. All right, check your answers. Make sure you did them right. All right, try these last couple on your own, and then it's time to complete homework. Scroll up there. Okay, page 84 to 85 of your textbook. Number 6, 10, 11, 12, and 14, A, B, C, H.